Good morning, mathematicians. We are looking at Wednesday. We're starting with some metric conversions, and we're thinking about liters, which certainly is like a liquid measurement. It's a measure of capacity in the metric system. So let's go ahead and let's think about all of these, how it relates back to this relationship. There are 1,000 milliliters in how many liters? 1 liter. That is the important relationship that really all of these questions tie back to. So if I have 1 liter and 400 milliliters, and I want to convert that all to milliliters, I would have 1,000 milliliters for this one, and also 4,000 or 400 milliliters. So I would have 1,400 milliliters for my very first conversion. The second one, we have 2 liters. Well, 2 liters is going to be double this. So it's going to be 2,000 milliliters. And then, of course, we will add this 652. So we will have 2,652 milliliters in that second conversion. For our next one, we have 10,000 liters. Well, 10,000 liters is going to be, or excuse me, we have 10 liters. 10 liters is going to be 10,000 milliliters. So we have 10,830 milliliters for this next conversion. Now, here we're asking ourselves how many liters and how many milliliters are in 13,200 milliliters. Well, we might ask ourselves, how many groups of 1,000 do we have here? We have 13 groups of 1,000. So that takes care of the 13 that we have here. The remaining value are the milliliters. So that's our 200. 13 liters and 200 milliliters equals 13,200 milliliters. Same thing here for our fifth conversion. If we have 22,725 milliliters, how many groups of 1,000 do we have in this? Well, that would be 22, and that accounts for how many liters we have. That takes care of this part of our conversion. And the leftover 725 stays milliliters. We have finished those conversions for our metric conversion question that we began with. Our second question for today is asking us to label the below number line with tenths. So I have done that here. On these intervals, I have labeled this one as 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, which is the same thing as 1. Now we are asked about this X. The X mark is most likely showing which of these. Well, if I look at where this X mark is, first of all, I can see that it's just a little bit more than halfway through the number line. But I also can think about how 5/10 is the same thing as 50 hundredths. And 6/10 is the same thing as 60 hundredths. This X is right between the 50 and the 60 hundredths. So certainly we can see that this is the answer we should select, 55 hundredths. It is halfway between the 5/10 and the 6/10, or the 50 hundredths and the 60 hundredths. Now let's come and think about equivalent fractions. Billy Eyelash needs you to use multiplication to find an equivalent fraction for each fraction below. Well, I'm going to use this. Actually, I'll come over here and use this to show what we're going to do. We are going to multiply our numerator and our denominator by the same number to come up with an equivalent fraction. I'm going to go ahead and multiply them both by 2. And I like to do it this way because it shows we're multiplying by a fraction of 1. This relates back to the identity property of multiplication. Anything times 1 equals itself. So here we're going to have 2 times 1 is 2, and 6 times 2 is 12. We've multiplied the numerator and denominator by the same number, and we've come up with an equivalent fraction. So my answer here for this one is 2/12, but certainly you can create numerous equivalent fractions here as long as you multiply the numerator and denominator by the same value. Let's do the same thing with 3/8. We need to multiply both the numerator and the denominator by the same value. I'm going to multiply them by 5 this time, but you could do 2 or 3 or 4 or 100, any number. Here we have 3 times 5 is 15, and 8 times 5 is 40. I have created an equivalent fraction of 14, or excuse me, 15 40ths. But you have truly an infinite number of equivalent fractions you can create. Now, in this question, we are circling the two that are true. The rest are untrue. Well, right away, I know this one is untrue. 1/4 is not greater than 2/4. Those are equivalent values. 1/4 equals 2/4. So that is not true, right? Now, this is a true statement. I know that 2/6 is equal to 4/12 because look, I've multiplied the numerator times 2 and I've multiplied the denominator times 2. So those are true values. Here with number 3, I know this one is not true. 4/8 is the same thing as 1/2. 1/2 is not smaller than a fourth. So this one is untrue. We're not going to circle that one. This one, number 4, is also untrue. 3/4 is not equal to 6/12. 3 times 2 is 6, but 4 times 2 would be 8. So this is not a true statement. Those are not equivalent fractions. If I've done this correctly, this one should be true just by the process of elimination. We know that we are supposed to circle 2. Let's see if this one is true. Is 3/6 smaller than 3/4? Absolutely, it is. 3/6 is the same as 1/2. And yes, 1/2 is smaller than 3/4. We have just one more quick question to do here. This says to circle the correct answer when comparing 4/3. That's greater than 1/2. And 3/4, ooh, that one's less than 1/2. We should use blank as a benchmark. Well, I just said it even as I read those fractions. We should use 1/2 as the benchmark because we know that 3/4 is greater than 1, and we know that 3/4 is less than 1. So certainly that tells us that this is going to be greater than this, right? So I could write that down below, 1/2, but indeed we have even shown how we would use 1/2 to compare those two fractions.